So, Grejo, I'll start.
Yes.
Okay. Good afternoon, everyone. It gives me immense pleasure to welcome our respected speakers, faculties, guests from other organizations, and our dear students to this discussion on sustainable engineering. The Engineering Committee across India is celebrating Engineers Day today as a remarkable tribute to the greatest Indian engineer, Bharat Ratna, Mokshagundam Vishweshwarya, popularly known as Sir MV. Engineers can play an important role in sustainable development by planning and building projects that preserve natural resources, are cost efficient, and support human and natural environments. The goal of sustainable development is to enable all people throughout the world to satisfy their basic needs and enjoy a better quality of life without compromising the quality of life for future generations. With this thought in mind, I would request our principal, our leader, Dr. Prasanna Nambiar, a passionate engineer who loves applying engineering to solve societal problems, especially in the tribal and the rural sectors. Ma'am, over to you.
Thank you, Priya. Thank you very much for those kind words. And thank you for setting the ball rolling on this very, very important topic, which I'm very pleased has been taken up by these students for a discussion on an important day as the Engineers Day. And I'm extremely happy to welcome all our speakers. We have a galaxy of speakers today, Mr. Ashok Kalbag, Mr. Vivek Pandey, Dr. Anand Rao, and Mr. Amit Tandon. Thank you so very much for accepting our invitation to be a part of this panel discussion. And we really we really look forward to listening to your viewpoints on this. So my dear students and faculty members who have joined in, very warm welcome to all of you too. Let me begin by stating that sustainability is probably the most widely used term today. Whether we are looking at sustainable goals or sustainability index, sustainable farming, sustainable living, etc., sustainability has become a buzzword. So what does it really mean to be sustainable? And is sustainability a means to an end, or is it an end in itself? This is an important question for which we need answers. Now, Don Bosco as an organization everyone would know has been a key player in promoting skilling, education, and empowerment of the underserved communities across the country. However, I must add that there has been no conscious effort to assess the sustainability of their interventions. So therefore, we need to ask some fundamental questions. Number one, how do we assess the sustainability of a product, a model, or a business? What are the parameters that define sustainability as against something being unsustainable? Is it only about meeting sustainable development goals, or is it also about impacting life and livelihoods? How can sustainability become a way of life? And how can we develop a sustainable mindset if there is something like a sustainable mindset? And more importantly for me as a teacher and as an educationist, my question, a very important question for me is, how can sustainability be embedded into our curriculum? So several questions for which we would like to have answers, and we have a very highly informed and committed set of panelists who I'm sure will provide us with inputs on all these counts. And it's my pleasure to welcome them to share their thoughts. So over to you, Priya.
Thank you, Prasanna ma'am. It's always good to hear from you these words, these inspiring motivational words. Thank you for this start. Now I would request Swati to take over from here. Swati, over to you.
Thank you, Priya ma'am. So good afternoon to the esteemed panelists, Principal Dr. Prasanna Nambiar, members of the Managing Committee, faculty members, and fellow students. My name is Swati Kamath, and I have the honor of being the moderator of this panel discussion today. The term sustainable development was popularized in Our Common Future, which was a report written by the World Commission on Environment and Development in 1987. They define sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Along the same line, sustainable engineering is the process of designing or operating systems such that they use energy and resources sustainably, while also leaving room for future generations to innovate and create. Our panelists today are experts in the field of sustainable engineering, each having his own distinct field of specialization under the umbrella of sustainable engineering. I would now like to begin this discussion by introducing our esteemed panelists. Mr. Ashok Kalbag is a member of the Managing Committee of Vigyan Ashram, Pabad. Vigyan Ashram is an NGO working in the field of basic technical education in rural India. He graduated from IIT Bombay with a BTech in Mechanical Engineering in 1974 and worked in Godrej and Boyce in product design and process development until February 2008, when he quit to become the full-time Secretary General of PAN IIT Alumni India. Mr. Kalbag helped drive nation-building initiatives like IUCEE, Reach for India, I Create, etc. since June 2012 and helped co-found Rural Initiatives Group of IIT Alumni Association, Mumbai chapter. The group volunteers time, effort, and resources towards alleviating hardship of rural India with low-cost appropriate solutions, which the villagers can take ownership and maintain themselves. Dr. Anand Rao holds a BTech in Chemical Engineering and an MTech in Environmental Science and Engineering, both from IIT Bombay. In 2003, he received a PhD in Engineering and Public Policy from Carnegie Mellon University. He has numerous publications and projects to his name, including serving as a lead author on a chapter of the Assessment Report 6 for Working Group 3 of the Intergovernmental Panel on Climate Change, which is a body of the UN. Dr. Rao is the head of department for the Center of Technology Alternatives for Rural Areas, IIT Bombay, or CTARA for short. CTARA offers MTech and PhD programs, conducts research projects and academic training programs, and offers technology and development supervised learning courses to BTech students in the institute. They work closely with several governmental and non-governmental entities to resolve challenges that arise due to rapidly changing perspectives, policies, and practices pertaining to technology and development, and study the interrelationship between the two. Mr. Vivek Pandey holds a BE in Electronics and Power from Visvesvaraya National Institute of Technology and an MBA in Technology Management from IIT Delhi. He is currently a Senior Deputy General Manager at Power System Operation Corporation Limited, the system operation arm of the Government of India. It is a wholly owned subsidiary of Power Grid Corporation of India Limited and is responsible for monitoring and operation of the Indian electric power grid. Mr. Pandey has several publications to his name and has worked on many projects like Santulan and Kabul, which is capacity building of load dispatch centers, which work to provide energy to all parts of India in a sustainable, stable, and efficient manner. He has a keen interest in issues related to power system operations, electricity market operations, and electricity regulation. Mr. Amit Tandon founded PolyCycl in May 2012 after working for Fortune 500 companies and startups. PolyCycl is focused on addressing one of the biggest pain points in the field of waste management, the challenge of recycling non-recyclable waste plastic. The company has worked over 150 man-years of research and development and has developed multiple technologies for chemical recycling and purification of different types of waste plastic. PolyCycl's flagship technology recycles mixed waste plastic to high-value petrochemical feedstock and fuel using a proprietary process that stands patented under several international patents. Mr. Tandon has led his team across 4 generations of technology development. He has been a speaker at various conferences related to circular economy and stability, including South-Southwest Eco at Austin, Texas, and the Asia Pacific Energy Conference in Manila, the Philippines. It is a great pleasure to have you all here today. Now, let me begin this panel discussion with a slightly general topic. Could all the panelists please give us some insight into your trajectories from being engineering students or engineers that worked in core industries into the area of sustainable development? And what was it exactly? Was there a specific incident that inspired that change? I think we can begin from Mr. Kalbag.
Good afternoon, and thank you for having me on the panel. To begin with, sustainable design or engineering, if you ask me, is more an attitude rather than any specific thing, because we need to design and think as to how we can do whatever we are creating. I mean, all engineers are essentially problem solvers. So there are problems and we need to arrive at solutions. So there is no one correct answer, but our answer and our goal should be to ensure that we use less and less of the resources to get more and more benefits. So essentially that boils down to what Dr. Mashelkar has been saying as frugal engineering, which is getting more with less. So there is no one end to it. It's like you always, every iteration should be a little more, so you get a little more benefit and use less resources. It's not that we don't come to a conclusion or don't come to a solution till such time that we are sustainable, but it is that we get a solution first and then keep working on it till we are happy with it being sustainable or it being even more sustainable than the previous version. So like I said, it has to be a kind of attitude and mindset for which you need to approach any engineering problem for which we are trained to get solutions. Now, right from beginning, one of the key things for becoming an engineer is you should be willing and interested in doing things. And all learning essentially comes by doing. So if you want to be a good engineer, you should be able to execute your ideas and not just on paper, but actually build it up so that you know what are the practical problems. And therefore, every time you are trying to come to a solution, find out and think out of the box. Don't think of it as which formula should I use, but go to first principles and then try to arrive at how you would find that solution. Because the moment you go to first principles, you are not boxed in with what has happened earlier, but only the basic principles which will guide you towards the solution. And you'll be surprised how often you will come out with different solutions. Maybe I could expand on that, or maybe as we go along, we would be able to go into some specifics. How would you like to proceed, Swati?
Sir, I think right now, if you can please explain what it was that actually inspired you to get into sustainable engineering, or your personal story.
I wouldn't say I was inspired to get into it, but like I said, if it's a mindset, then my mindset right from beginning was that I should be able to design things with using the simplest possible solution, meaning simplest in the sense of least material, least cost, and then arrive at a solution. Let me say, right from my engineering days in IIT, we had, at that time, we had 5 years BTech course in IIT. And we had 1 month of in-plant internship at the end of 3rd year and at the end of 4th year. So as a mechanical engineer and interested in automobile, I decided to do it in Mahindra and Mahindra and Premier Automobiles, both in Bombay, both automobile, and convenient for me since I also stay in Bombay. After going through these internships, I realized that even a BTech, which I hadn't completed, but which I was in the process of doing, I began to realize that a BTech is an overqualification for the kind of problems that exist on the shop floor quite often. And there are so many problems in our country that it's a waste of time trying to study more and more instead of getting hands-on and So to that extent, I can say that after my BTech, I decided I'm not going to do any post-tech because it would not be worth my while to do more academic work rather than get hands-on and start working and solving the problems. So to that extent, you can say that I was inspired from being a student.
Thank you, sir. Dr. Rao, if you would like to jump into this conversation.
Yeah. Shall I say something about CTARA from where I come from? So that will give some background. Is that okay?
Yes, sir. So, yeah, of course.
Okay. So I'll just like to share my screen.
Yes, sir.
Yeah. Namaskar. Good afternoon, everyone. So I just quickly try to give you a background where I come from. That is CTARA. Thanks a lot for the nice introduction. So this is the small center within the large setup of IIT Bombay in a very beautiful campus in Mumbai. So CTARA is slightly different from the other units across the campus, slightly because we believe celebration of technology, I mean, more in terms of how it contributes to the development. So we try to celebrate development through the channel of technology. So we look at technology as a means to achieve a larger goal of development that we have been always talking about. Now we talk about sustainable development. And for that, we have this specific focus. It has been traditionally looking at the region that we are in, that is Konkan or the Western Maharashtra region. And so more in terms of some field orientation and action. So that has been a unique point that CTARA cherishes. And then over the period of time, what we have seen, the overall general context, if we look around, so the kind of development paradigm that we are following, which is industrialization, urbanization, and consumption. So these are the three basic terms that we often hear about. All of them typically promote unidirectional flow of resources, which is drastically against the basic principle of sustainability. And what it has resulted in is the rapid economic growth, but with increasing disparity. And now we have this stark contrast of India versus Bharat. And we often see that the villages are dying and then the cities like Mumbai are overburdened. So in all this context, what is the relevance of education and research, and especially higher education that we deal with? And in this context, we'd also like to review this basic question whether technology is a part of a problem or a solution. We always believe as a technologist or an engineer that technology is a very useful tool and it can address a lot of issues and problems and provide solutions. But we have to also pause and see what are the externalities of technology and whether technology is always a solution or it is leading to new problems that again some new technology has to deal with. So there has to be work done on the interface of what we call technology and then the larger development. So in that context, we try to develop an academic program in IIT Bombay with the theme of linking these two terms, that is technology and development. So the idea is how we can train professionals who are trained in technology but are sensitive to the larger needs of development, and they can work on this interface of technology and development. So with that thing in mind, we try to enlarge our canvas to work on this theme of interface of technology and development, which basically requires a lot of interdisciplinary work, a lot of field orientation in the work, and then the focus has been on the unorganized and marginalized sections of the society, and then working on the externalities of technology. That is what we have been promoting. And then one of the key points is the research has to be demand driven. So rather than developing something in the lab and then trying to find out who can use our solution, first try to interact with people and find out where the shoe is pinching, and then try to find out the solution accordingly along with the people. So this has been the kind of approach that CTARA has been taking. And then as Professor Milind Sohni, our former head of CTARA, portrays, and he has a lot of talks available on his website as well. So university in today's context should play an important role of knowledge generators, but it should also link the people at large and the industry and the government. All of them have to evolve this ecosystem where the universities can support people's students to tackle the problems that the society is facing. And that's why this whole issue of having professionals trained to deal with development situation is very, very important. And in that aspect, which is an interdisciplinary program which is open to all branches of engineering and science, where we hope that we can train development professionals who can deal with this situation. And then one of the unique part of this program is the summer field work, where the students stay in a rural household for about 2 months. Relationship, the resources and technology linkages in that particular context, and that helps them to find. This is a kind of a journey in the search of sustainability that begins at that early age. So just a couple of points I would like to make if time permits.
Yes, sir.
Yeah. So when we are trying to think about sustainable engineering, I was just trying to think aloud in terms of connecting sustainability and engineering. So coming from the environmental engineering background, I would like to focus on the environmental aspect. So typically, if we look around today, we find that environmental compliance is considered only as a peripheral issue. So it is one of the check boxes or tick boxes that need to be there when we are thinking about production of any particular commodity. However, what we need today is some kind of a mainstreaming of environmental concerns in the engineering itself. So we have engineering of various kinds, civil engineering, mechanicals, chemical engineering, etc. And environmental engineering just happens to be one more branch of knowledge where the environmental engineers are supposed to deal with all the pollution and other problems of externality created by all other engineering disciplines. So rather than that, it has to become a central point when we try to design products. So this whole field of green chemistry and green manufacturing has to have a lot of emphasis. As Dr. Claude Alvarez nicely puts, we have to learn from nature. Nature is a perfect example how things can be produced perfectly, but also nature has this capacity to deproduce things that the nature itself has created. So all the waste, natural, whatever flora, fauna, whatever waste that is generated in the nature, it gets disassimilated very easily over a period of time. Only natural systems can do that. And now we have to think about how we can create products which can also follow the same industrial ecological principles. So I think it is very important that we develop this holistic or systems thinking and the overall life cycle approach when we look at engineering, and that will go a long way. Now, coming specifically to think about rural areas and innovating solutions for this, I think the approach has to be need-based or demand-driven. So that means we have to first understand what people want or what they are looking for. People's perceptions are very, very important, and we have to understand whatever we are trying to promote, is it going to be acceptable to them? We have to find out their aspirations, and that's why the ground reality check is very, very critical, so that whatever is being implemented, whatever intervention is being designed, how it can become sustainable over a long period of time. So that so the commitment or involvement of local people or engagement of these stakeholders is very, very critical. And that's why, as Professor Date, our founding head of CTARA, as he puts it, we have to design technology as if development mattered, and then we have to design solutions or innovate along with people rather than for people. I think that kind of an approach will ensure sustainability of whatever engineering or technology solutions that we are trying to provide. I think I'll pause here for now. Thank you.
Thank you, sir. Mr. Tandon, I specifically wanted your insights along this topic, especially as someone who came from working for some of the biggest companies in the world to then having your own startup, founding your startup in green technology specifically. What was that transition like? Sir, I think you're unmuted. You need to unmute it.
Yes. So can you hear me now?
Yes, sir.
Sure. So thank you for everyone at Don Bosco and it's a pleasure to be part of this panel today. So Sati, your question is around the personal journey, and for me, I have a background, an academic background with computer science. And I studied that, and maybe over the next 10 years after finishing university, I was working in the field of computer science technology, in semiconductors specifically, and both in India, but a bigger part in the US, where I was also, I worked at some large companies, as you mentioned, but also with very small companies. Some were 4 or 5 people, just recently startups. And, you know, that really got me introduced to the whole concept of, you know, how an entrepreneurial energy and how people coming together could bandy together to solve, you know, problems that they have strong resonance with, using first principles, as a speaker alluded to before, as well as, you know, how a startup has kind of become an entrepreneurial engine for attracting similar forces, which are co-aligned with solving that problem. So when I relocated back to India, which was late 2006 or so, you know, there was this emerging field. In fact, I believe the term had just been coined. It was called clean tech, which I'm guessing now most people have heard, and even in universities fairly well understand. So it was a term that was coined around that time, which was this emerging field of industry, which was looking to solve some of the larger problems that humanity is facing. You know, and that included problems in, for example, the field of waste management, but also things like decarbonization, better and more greener forms of transportation, a smart grid, and so on. So, you know, there was a gamut of problems which this emerging field and was looking to apply itself to. So I was quite drawn towards it, as I believe Mr. Kalbag also shared priorly, that, you know, engineering is a lot about just using first principles and a basic understanding of how do you deconstruct a larger problem into smaller problems and try to go attack and solve them to bring together the entire jigsaw. And so so I gravitated strongly, you know, to as part of certain, there were a series of events that led me to gravitate strongly towards working with the challenge of waste plastics. It was also that you saw it littered all around, but also that it seemed to me that it should be possible to essentially forge or build an overarching endeavor in this space, which could be a triple bottom line effort. So, you know, it addresses the pillars of economic sustainability for the project and the technology, but also the social and the environmental aspects in terms of what it is achieved, especially when done to scale. So the early years were spent mostly in, I brought no academic background for this. In fact, it took me a couple of years to really even figure that, you know, in some ways to plumb my own capabilities towards what eventually came to be towards leading engineering design. But it was a step-by-step process as it happened over a period of a couple of years. So yes, so that's been a bit of our trajectory arc, and I have always thought that, you know, education is in some ways what remains with you once whatever you've learned at school, college, or university level is forgotten. what the residue, the remainder that stays with you, and that is the education that you have imbibed over the years. And in many ways, it comes back to just first principles. So over years, I probably didn't have the confidence back then as I have now, but I now have started to see that the disciplines of engineering are essentially just helping us, irrespective, the various disciplines are all helping us with the same things, which is about building a framework, a structured framework of understanding how to go and solve problems. And if you essentially learn how to learn, then essentially you could leverage that understanding to go and solve very different kind of problems than what your academic career may have prepared you for. So I would be happy to speak more about the company as we go through, but that was to answer the personal side of the trajectory leading to the work I'm doing now. Thanks.
Thank you, sir. Mr. Pandey, if you can just enter this conversation, talk about how your journey went from being an engineering student to now working in a governmental organization.
Namaskar to my fellow panelists, and very good afternoon to all those who are online. It's my pleasure to be here speaking such eminent panelists along with them, and also to educationists and students. Actually, my own personal journey has been rather like at an individual level. If you see, when you come out of college, the first thing is that you want to stand on your own feet and then start thinking what to do next. So the first lesson on sustainability was a very, very personal one: how to sustain oneself in a very competitive world and in a very complex world. Then coming to further journey, since I was in the power sector, and specifically I have been in a role which deals in a very multi-stakeholder environment, where we have people with different interests operating in a power sector. Like we have generators on one end, consumers, then transmission utilities, there are distribution utilities. And over the years, now we have regulators and so many diverse market players that have come in after opening of this sector. So the realization came when the market started opening up, the power sector market started opening up, and we needed to have, we came out of that monolithic structure of only one company producing, distributing, and collecting revenues and everything, supplying. So we came out from that, and then we had multiple players. Then whatever solution or whatever mechanism that we had to create, the first thing that we had to think that it had to be sustainable. It should not be an open-ended system wherein only one side says what to do and the other side, you don't listen to the other side. So instead of being an open system, it had to be a closed loop system where you listen to the voice of the consumers, all sides, rather, I should say all sides. Because power system is such a intricate system wherein you have social aspects running shoulder to shoulder with extreme high engineering aspects, technological aspects. And then since it is so ingrained in our society now, electricity is such an essential item that we can't really imagine life without power system and electricity, and having access to that electricity, reliable and round the clock electricity. So that was there. And then in 2007, when I did my MBA, there was one particular subject on creative problem solving. So that appealed to me a lot, and I think that set a lot of things rolling in my mind, that there are so many issues around us, there are so many diverse problems. So the first thing that we need to have is identify mess finding, that is, what is the problem, defining the problem. And many times the problems, though they, after you have arrived at and defined that problem, it comes to a very simple and a very small problem, but it reflects in so many diverse ways, and it's very difficult to reach at that simple problem. So identifying the problem is the first thing. And once that is done, then you have multiple ways to solve that problem. And we have to choose the way which can sustain the different challenges. Like it has to be cost effective. If I speak of electricity, it has to be reliable electricity, and at the same time it has to be affordable also. We can have there are so many ways of producing electricity. You can have tidal wave, or you can go, even in our country we have a huge coastline, we can go offshore wind farms. But then are they really producing electricity from those sources? Are they really affordable for people like us? So that is where we had to identify solutions. And then what do you do with the legacy systems? As and when we proceed, we try to identify new ways of solving or new ways of producing electricity. But then what do you do with the system that you already have? For example, now we have around 60 to 70% of our power coming from coal stations, coal-fired stations, and those conventional technologies. And a huge number of people are employed into those, and there are a huge number of assets that have been created. Now, overnight, you can't simply junk those assets and say, no, from tomorrow on, we'll switch over to green energy altogether. So there has to be a transition. There has to be an understanding of that from this place onwards, how do we reach to our desired goal? And at each step, you have to take care of all stakeholders that are into the system. So personally, that was the thing. And also at an individual level, I believe that yes, we need to be adopting a philosophy of minimalism, wherein we take as little as possible, consume as less resources as possible, and in fact we give back to the society more than what we have taken from the society. So to me, that is sustainability. If we are able to do that and achieve that, then we would be able to create a sustainable society, and to be very specific, in my case, sustainable energy systems. So we can talk about more. I'll stop here.
Thank you. Thank you. Now I'd like to move on to slightly more specific questions that our panelists can answer. I'll be directing these questions to specific panelists, but if the other panelists have something to offer to the conversation, they are welcome to join in. This question is directed at Mr. Kalbag. Mr. Kalbag, can you please tell us what Vigyan Ashram is, what you do there, and how exactly it falls under the realm of sustainable engineering?
Well, let me begin by saying that Vigyan Ashram was started in '83, and the whole idea behind Vigyan Ashram was that there is a big divide between the urban population and the rural population, though the majority were in the rural population. And the benefits of science did not percolate down to the rural population. So that was one of the ideas with which Vigyan Ashram was set up. Pabal, where it is located, was selected because it had maximum problems. I mean, in Bombay, this year, for instance, we have got more than 3,000 millimeters of rainfall. But in Pabal, you normally have less than 500 millimeters. So groundwater was a big problem. So agriculture was a problem. I mean, you just look at it and everything was a problem. So what better place? If you could succeed in Pabal, then you could probably succeed anywhere else, because most other places would probably have less problems. So that was one of the ideas with which Vigyan Ashram was started. More fundamentally, why the name Vigyan Ashram? Vigyan basically implies science, and the thought process has to be scientific for any problem solution. And therefore the name Vigyan. And Ashram connotes simple living, high thinking. Therefore the name Vigyan Ashram. Anyone, and I think some of you are familiar and have visited Vigyan Ashram. When you visit Vigyan Ashram, you realize to what extent we have gone in simple living. And rural and simple living doesn't necessarily mean that it is low tech, because a lot of people have misconception that rural means it has to be not very technical and all that. We do have highly sophisticated things and solutions that we come out with. Our fundamental goal, like I said, is how can we get something minimum and get maximum benefits out of it. Just to give you a small illustration, in the initial stages when we were trying to develop what we call a mech bull, and how did we come across development of the mech bull? In rural areas, particularly in places like Pabal, you need 2 bullocks for doing your agricultural work. And in a place like Pabal, you require them only for the initial period of the monsoons when you do agriculture work. Rest of the year, you can't do any agricultural work, very simply because there isn't enough water. And therefore, how do you maintain those bullocks for the whole year? Very often, you have to sacrifice yourself what you can consume so that your bullocks will get them. And therefore, the idea came up as to how to come across a sustainable solution for this. And a mechanical bull, that's how mech bull name came in. It had to be for less than the price of 2 bullocks and do the work that 2 bullocks do all the time. And when not required, it could be put away. So there is no recurring cost on maintaining that mech bull. So that is how we worked on it, and that is how we developed that product. And when most of the mechanical tractors at that time were at least 5 or 6 lakhs, we were able to develop something like this for under 1 lakh. And we did find a local person who was willing to take it up and make it, build it and sell it. And by word of mouth, he was able to make and sell over 20 of them till the Mahindras themselves, in fact, came across this, and they decided that they would like to take it up on a much larger scale, and they came up with a slightly more expensive model, but essentially similar features. So that is how we look at it as a sustainable model. And like Anand also mentioned about CTARA, we also look at what are the problems and that people are actually facing. And if they do have that problem, how can we solve it so that they can fruitfully utilize it? There's no point in having a solution which they can't afford or they can't operate. So once the solution is taken up, then we want that they should be able to take and run with it, maintain it, and we can withdraw and look at some other problems. So from that perspective, any problem that we take up for development or for design is first identified as someone who is a customer, meaning someone should be there who's willing to put his money in and take the product. We decide on what should be the product, at which rate he will be willing to accept it. And therefore, that is the price limit that we work on. And then we try to see if we can develop. The first product that we develop, the developmental cost, obviously, will not probably be able to load it on the first customer. But we try and meet all his requirements. And practically all our solutions have developed on that basis. And we also believe traditionally in India, all knowledge was society owned. So we do not take out any patents for any of the developments that we make. And we are willing to share it with anyone who wants to take it. So we have a complete manual for many of our developments and the complete designs which we can hand over to anyone who wants to take it and start. And that we believe is what makes it very sustainable for all the others also to go ahead. You want any more things or?
No, sir, I think along the course of the discussion, we can speak more about
Sure.
it.
Thank you.
So, Dr. Rao, along the same discussion of innovating for rural areas, I just wanted to ask you, what is the sort of challenges that one may face while innovating for rural areas? And also, is there any specific anecdote that you would like to share about some challenges that you face?
Yeah, thanks a lot for the question. As I mentioned earlier, I think one of the critical requirements when we are designing anything or working with rural areas is trying to understand the context very well. What exactly is the problem? So problem definition many times takes sufficient time, and then we need to provide that time, because otherwise we'll be probably attempting to solve a wrong problem itself, and then that may lead to further series of problems in the same place. So when you're asking in terms of any specific anecdote, so I just give a couple of general examples. One is, I mean, in the area of energy, especially cooking energy in the rural areas. So we all of us know that even today, majority of the rural households still continue to use the solid biomass for cooking, which is a major cause of air pollution and then the impacts on respiratory health in rural areas. And in spite of whatever efforts from both government side as well as the non-governmental organizations in terms of promoting the so-called improved cook stoves or smokeless stoves, then technologies like biogas, and then many other renewable energy solutions, still there has been a very limited success in terms of promoting these solutions. Part of the reason is that trying to understand people's priorities in terms of what exactly are they looking for, their cultural practices, the kind of association with their traditional cook stove and culture associated with that, the food preparation and the habits. So there's so many aspects related to this. So if a mechanical engineer generally is given a task to design a good cook stove, the person may do the work in the lab and try to come up with an efficient cook stove that can burn biomass. But still that may not serve the purpose for the local community, which is supposed to use it for their own good. So this is one of the things that has to be taken into account when we are going to some place to solve an issue that we feel that it is affecting those people, but first trying to understand the linkages, the nuances in that particular context. So that is very, very important. So similar thing has happened with respect to even a so-called more benevolent technology like biogas. So biogas is considered to be a very win-win kind of a situation in the renewable energy sector, because it tries to address both waste management as well as the energy security aspects in one go. So on face of it, it is a very good technology. And then we hardly find any reason why people should not accept it. But when we go to rural areas and we have done some surveys, and then so this technology again was promoted on a large scale by the governmental schemes to promote this technology on a large scale to by giving various kinds of incentives. But now in today's context, when things are changing rapidly, we have to see what is the relevance of this technology. So when LPG becomes available, or when keeping bullocks, as it was mentioned, keeping bullocks itself is, or cattle is itself is a very expensive proposition. So as the farming practices are changing, the cultural systems are changing. So whether so who will do the manual labor required to run the biogas plant? So there are so many things that we found in the survey, that even if people have a biogas plant in place in their household, still they are not using it or not interested in repairing. Another aspect related to this is there is no trained manpower to service these plants. So somebody comes and installs these plants and disappears, and then the owner does not have an access to a regular maintenance of this plant. So there are so we have to think about the complete ecosystem when a technology gets planted in a rural setting, how it can sustain over a long period of time. So there are challenges related to this. Thank you.
Mr. Pandey, along the same lines as well, because you work for Pan India electricity supply. What are some of the challenges that you faced in your several projects that you've worked under?
Yeah, actually, the government's commitment towards this green energy and clean energy has been there. And all of us are aware of the significantly high targets that have been set, and they are being aggressively pursued. And then there are so many incentives that are being offered, and there is a big push to increase our installed capacity in terms of wind and solar power stations. So being a power system operator in POSOCO, we are responsible for maintaining the instantaneous balance between the generation and the consumption side. They have to be perfectly in balance to enable the system to remain secure and reliable and continue to operate in an integrated fashion. In fact, very few people would be knowing that presently the entire country is interconnected into a synchronous system. And in fact, we have the neighboring country of Bhutan, which is also operating at the same frequency. Like it is like the entire subcontinent operating at same heartbeat. So that is the challenge that we have. So hitherto, whatever conventional stations we had, the coal stations or the hydro stations, the nuclear stations, they are all very controllable. Like we could regulate them as per the requirement, because the demand of electricity doesn't remain steady around the clock. It keeps varying. For example, in the morning hours, it shoots up. Then in the afternoon, there is a slump in the demand, and then evening peak again, it rises. And in the night, again, it subsides like that. So it keeps varying. So now we had all the practices and procedures, everything existed to handle all these scenarios. But the moment we started with having higher percentage of this intermittent and variable energy resources, then the challenges of system balancing started increasing. And that is where we started looking for solutions to balance the system through, because in fact, we are not very much blessed with hydro resources. We don't have large reservoir-based resources. Most of them are run-of-the-river power stations in Himalayan, which are fed by snow, and the inflows are very, very unregulated and unpredictable. So to that extent, unlike some other countries, we are not very blessed with large reservoir-based hydro stations or gas stations, which are extremely flexible to allow regulation of generation as per the demand. So we had to depend only on the conventional stations, and that is how, and a lot of regulatory changes were required, a lot of policy changes were required to how to introduce flexibility in the thermal coal-fired stations to respond to fast changing needs of real-time operation. So a lot of things are being done for having a flexible operation as far as the conventional stations are concerned. And then new market mechanisms also we are introducing. Like for example, we have ancillary services wherein even dispatch of electricity for a very short duration of time, that has to be possible. Instructions have to be sent quickly, and the generator has to receive those instructions and vary the generation, either increase or decrease. So market mechanism also have been, to a limited extent, they have been introduced, and we are exploring how to mobilize more and more flexible resources to handle the challenges of renewable. Then on the other hand, there was another thrust of the government to, as I also said about the utility, at the utility level, there is a thrust to provide access of electricity to as many, the maximum household. In fact, almost 100% target has been achieved. The rural household electrification, the access has been provided. So the challenge was how to sustain all that, because the moment you keep expanding the grid, then you have a challenge of maintaining those systems which are very remote. And to maintain those systems, you need to have visibility of the system at the control center level, and then metering of those feeders, then revenue realization, so that the utility which is responsible for supplying that electricity, they must get back the revenues. And then how do you create a demand or a desire for people to consume more and more renewable energy? Because if you see the installed capacity in our country, we have more than what we require. In fact, we are 100% surplus as of now if you look at the installed capacity. So how do you incentivize the utilities, the distribution utilities, to procure more and more of green energy and replace the brown energy? Okay, so for that purpose, a mechanism of renewable energy certificates have been created. Okay, and the regulator gives a purchase obligation to all the utilities that by the end of this year, the entire energy needs, a certain percentage has to be from green energy. But then the green energy resources are not available everywhere. They are scattered around the country. So wind is at the coastal areas, the solar would be in say Rajasthan area or other areas. So there is a disparity. So what we did was create a renewable purchase obligations on the utilities so that they are pushed to purchase and replace their brown energy with green energy. And on the other hand, the supplier side, we created a renewable energy certificate mechanism wherein every 1 megawatt hour of energy generated from a green source was given a certificate which could be traded in the market. And who would procure those certificates? One who is not directly procuring the energy, green energy. They could either procure green energy or you procure a certificate. So this kind of flexible regulatory mechanism has been created. So all this is giving a big push towards shifting from the coal stations and coal energy to the green energy. Then at the industrial level, there was also a requirement of, in fact, we do have a requirement of demand side management, and how do we cut down the consumption itself. We have a lot of energy intensive industries, like we have steel plants, aluminum plants, and fertilizer factories. So there are guzzlers of energy. So how do you incentivize them to adopt more and more efficient technologies? So this entire Energy Conservation Act was brought in 2001, and still the push was not coming. So PAT mechanism, perform, achieve, trade. This mechanism has been created, wherein the industries are given a target that within a year, if you are able to bring down your energy intensity to this level, you will get one energy saving certificate. Okay, so if they are able to save 1 megawatt hour of energy, then you get one energy saving certificate, and that energy saving certificate can be again traded in the market. So additional revenue sources have been created so that they are incentivized to adopt more and more efficient technology and reduce their consumption itself. So multi-pronged strategy is being adopted to push all this, and POSOCO is associated with both of these mechanisms, the REC as well as the PAT mechanism. So at the supply side as well as the consumption side, we are trying to encourage this sustainable energy systems.
Thank you, sir. Mr. Tandon, I was wondering if you could tell us a little bit more about PolyCycl and about what the work is that you do and how you do it.
Sure. So I was wondering if maybe a good way to do this is show a couple of slides that would help put.
Yes,
sure. So let me just share my screen then. Okay, so is my screen visible?
Yes.
Perfect. Very nice. So essentially what the company does is we over the last several years, we have been working, my team and I, we've been working to build multiple technologies that can work with the category of plastics that till now is largely taken or believed to be non-recyclable. So, you have a lot of single-use plastics, you have polythene grocery bags, flexible film plastics, including multi-layered plastics like from, packets of chips and so on. So globally, this is not just a phenomenon in India, but just globally, close to 99% of all kind of flexible film plastic is not recycled. And largely there are statistics that say that, since the advent of plastics over the last 50, 70 years, we have recycled a very, very tiny part in single-digit percentages of all the plastics that was manufactured. So the intent of the team here is essentially to go build new and novel technologies, which are presently missing to complete this jigsaw, where you can take plastics that are being landfilled, that have and can provide them a next life solution, or maybe even better, if they can be moved down a path of circularity where they can be used to go and manufacture new virgin plastics. That would help reduce the amount of new plastics that we have to produce as a humanity. So that's the larger goal on which the company is based and working out of. Our R&D center is in Chandigarh in North India. And let's go through this. So I think the problem statement is fairly well understood. The plastic production since 1950 is close to about 10 billion tons at this point of time. It's an impossibly large number to put our heads around. Plastics is also a very versatile and useful material. Even though a lot of single-use plastics has got banned in different parts of the world, but plastic production is continuing to grow at about 3 to 6, 7% year over year, because plastics is finding its use in new different kind of commodities. For example, now we have the rise of electric vehicles. A major part of their bodies is plastic. Plastics is being used more and more in construction. As you have the population that's growing, the consumer per capita use of plastic is also growing. So there are structural reasons as to why plastics is going to remain an integral and maybe an important part of the material or the synthetic material mix that we produce. And if you look at it closely, the problem statement really isn't so much about this versatile and material that has so much of application and use from the field of medicine to the field of space, but it's in what happens at end of life. The problem point is there. And we have not, largely it's been a failure. We have not been able to build the needed interventions at the right cost point where recycling infrastructure can be built and uses cost economic and cost viable structures. These plastics can be recycled. So our work is an attempt and endeavor in this domain to go solve these problems. So, it did come as a surprise when I realized that global plastic production today exceeds all man-made materials except cement and steel. So after cement and steel, plastics is the largest created man-made material on planet Earth today. And there are many structural reasons as to why this trend may continue the next couple of decades, even though, there is this consumer, a very legitimate and valid consumer, as well as other stakeholder-driven backlash against excessive and needless use of plastics. So what is our solution? We essentially can take plastics at the landfill site. So if you go at, most of you would have seen there are mountains heaps. For example, I know Mumbai has a couple of them, where you have legacy waste lying for decades, at times across several hundreds of acres. And it's a huge environmental and it's a huge environmental problem. It creates leachate. There's also embedded calorific value. Plastics, as you would know, is manufactured from the process of crude. And so they are very high calorific value materials, the embedded energy of which has not been recovered, and they're lying waste and creating a lot of toxic after effects once their consumption once in their post-use life. So what the technologies enable is to take certain resins like LDP, HDP, polypropylene, polystyrene. So it's a fairly large funnel of plastics that the technology would accept. We built what is called a depolymerization technology engine. Plastics are manufactured in a refining process, which is called polymerization. So this is essentially a reverse process that breaks the long chain hydrocarbons in plastics to generate shorter chain hydrocarbons that you typically tend to see in fuels. And now these fuels these are hydrocarbon feedstocks. They have many downstream uses. They can, very importantly, they can actually be used to go back to manufacture new plastics. And we believe that's a very aspirational and promising part of the solution being built, that you can actually go from plastics to a kind of fuel that can go back to pre-existing petrochemical feedstock, pre-existing petrochemical infrastructure. I mean, the same companies using the same infrastructure that manufactured plastics can use these fuels to manufacture new plastics, which means that done at scale, the technology offers the potential over time to achieve the phenomena of what's called peak plastics. Peak plastics is the phenomena that even though consumption of plastics may increase, as it is posited to increase at this point of time, because plastic is finding more and more utilitarian value across different aspects of human experience. But however, the amount of new plastics you have to manufacture will be on a declining curve. So there are certain models which suggest that this may be achieved from any time between 1927 to 1940. So maybe a decade to two from now. And technological solutions like this and others are likely to play an important role in inflecting the curve on production of new plastics. So because, I'm sure from an engineering student standpoint, you're interested in some of the high level, parameters. So you go from a ton of plastic, which is 1,000 kilograms, a metric ton of landfill plastic, let's say polyethylene bags, to about 850, 870 liters of fuel per ton of plastics. So that's a pretty good mass balance in favor of liquid fuels that can go back into a circular economy for plastics. And it's also important, we've realized, and I'm sure many students also do, and it's probably an important part of understanding sustainability, is that sustainability is a very good intent driver for example, for the team or a group of people to come and try to go solve environmental problems that will promote greater sustainability. However, unless you have the right form of economics at the underpinnings of the solution that you are building, it is likely not to find large-scale replication. So in fact, we see that in even now, even if you look at the matrix of all kinds of waste that is produced by humanity, which includes paper, cardboard, metals, aluminum, tin, and all of this, you'll see recycling rates are much, much, much higher. In some cases, recycling rates are as high as 90% plus. However, on plastics, globally, the numbers are as close to 9%. And a big part of that is that we don't really have an economically cash flow positive mechanism to go recycle plastics. And this has been an aspiration right from the word go for our team. And, so the way the technology is architected, these are municipal scale projects. So they will take plastics at a landfill site where they're available at scale. When we say scale, we are speaking about projects in the range of maybe 10, 15 tons to maybe even 100 tons kind of a projects, which is very, very large quantities of plastics. Maybe like, to give a sense of this, Mumbai at the landfill site, maybe they have 300 to 400 tons of plastic coming in every day for the greater Mumbai. And so, you could put a couple of these projects and they will accept all of those non-recyclable landfill plastics and convert them to high value fuels using positive project economics, which will be in the range of 40 to 65% of positive EBITDAs. So that's the aspiration and the potential on these technologies. To give you just to put your head around some of what kind of plastics it takes. This is single-use plastics. These have been mined from heaps, which are, some of these heaps are decade-olds. And you can see the plastics are dirty and contaminated. And they have been removed at the landfill site itself using density-based and air-based separation methods. So using mechanical methods, non-manual methods, you can essentially separate them at scale. And they can be then brought to the conversion engine, the depolymerization engine for conversion to liquid fuels. And those liquid fuels can go to naphtha steam crackers for manufacturing of new plastics. So that's the kind of a circular economy arc that we are looking to be a part of. These are the quality of fuel distillates. We do certain post-processing steps which actually refine the quality of the fuels, remove the certain contaminants, for example, additives that were added to the plastics, which have many minerals and metal atoms, etc. They are removed from the plastics to create a high-value distillate. Those contaminants are actually very safely captured either as part of a carbon charge stream or as part of your ETP sludge. So, they typically are less than 1% by weight of the input feedstock, and they are very safely captured as part of these operations. This is a video, but in the interest of time, I'm not going to play this. It's about a 2-3 minute video. It's also available on our website. In case somebody's interested, they could go and take a look over there. It shows the demonstration plant and the conversion process. Couple of photographs. This is the quality of the distillates that is coming from the waste plastics. This is what we call a middle distillate. It has properties very similar to diesel, but we don't believe that a good pathway is for this to go to transportation diesel, but more towards an industrial blend stock for diesel. This fuel is very similar to naphtha or gasoline. There are pathways for this to go to to transportation, to aviation fuel, to green chemicals, to benzene, toluene, xylene, and so on and so forth. A bit on our timeline, we did done, and maybe I just put in this slide because to give also a sense to engineering students that, it takes time, and it has taken us more time than what we imagined when we got started, which was almost 7-8 years back. I think it's just the very nature of innovation. You are pushing the envelope on and doing things which have not been done, essentially, at least to the scale or to the industrial scale at which they are being attempted now, within the framework they are being put together. So it is very hard to see past the corner. These are the questions are first available to you, but sometimes finding the answers takes not weeks and months, but years. And even then you continue to iterate to more optimal answers based on your research. So it is often not possible to see past the corner. You have to walk the blocks and then look further to see what are the residual set of problems that need to be solved, or a new set of problems that you never knew existed that need to go and be solved. So for us, this has manifested in terms of generations. We are at the 4th generation of technology deployment. At this point of time, we are commercial ready in terms of technology. So we went from a batch, a semi-continuous, fully continuous. So fairly, going back to first principles of thermodynamic engineering, of reaction kinetics, of heat and mass transfer, doing a lot of reactor design, putting together the team, from backgrounds having petrochemical, petroleum, but also industrial, mechanical, electrical, instrumentation, waste management. It's a fairly multidisciplinary team to work on the problem. And these are projects that, these are unsolved problems, not just in India, but in other parts of the world. Our aspiration is to go and deliver these technologies to whoever needs them and wherever they are needed. The fuel has been established for circularity, which means that it can actually go. We work with petrochemical majors like Shell and so on, which have studied and analyzed the fuel, that it can be accepted by their pre-existing infrastructure to manufacture new virgin plastics. This is some part that I've shared before on project commercials. I think what we're trying to achieve over here is that present systems are, what they call the linear economy. It's a take, make, and dispose. So for example, on plastics, you take crude from the ground, you extract crude from the ground, you use it to make plastics. Many plastics, maybe about 50 to 65% of plastics, which go into packaging, have a very brief life. So after that very brief life, where they are then go to the dispose cycle, where they are now either they're littered, or they land in our water bodies and oceans, or at the landfill sites. So that's also called a cradle to a grave, kind of a technology, a kind of an arc. You take, you make, you dispose. What the technologies that we and other companies are working with in this space are saying, okay, so the problem statement is really at the landfill site. These are essentially non-recyclable technologies. Can we pick them up from this point of time? Can we do something useful? Can we move them to some kind of a commodity that essentially has limitless offtake? And if you are able to do all of that inside a cost viable, cash flow positive structures, then you suddenly have legs to run, and the problems can be dented and solved in over a period of time. So in this case, it will from landfill go to some kind of liquid distillates of fuels, which will go back to petrochemical companies who manufactured these resins, and they will essentially go back to food grade new resins using pre-existing infrastructure. So that, instead of a cradle to grave, now becomes a circular economy. Okay, and in doing so, you save on carbon dioxide emissions. There's a lot of life cycle analysis studies that affirm that you save on the total amount of energy that is consumed in making new polymer. There's almost a 95% savings on water. Over time, you can help go solve the problems that there's a lot of plastics in water bodies, in oceans. So it took us 7 decades to come. I mean, mass manufacturing of plastic started in 1950s. So almost 7 decades, 70 years, we have essentially allowed this problem to come to where it is. And so it is going to take us some time, but maybe not a whole lot, because today there is a coming together of different stakeholders. I think there is a coming together of intentionality of wanting to do this. And so you have petroleum majors, you have petrochemical resin manufacturers, you have recycling companies, you have governments enabling legislation, you have technology startups like us, and there are many of such companies working in different parts of the world who are all looking to come together to build the jigsaw. And hopefully through the work of all of these stakeholders, as also the consumer, who will push back, ask the right set of questions, push back on single-use plastics, reuse much of the plastics, or maybe the highest contribution from consumers is still avoidance. I mean, there's nothing better. If you can reduce the amount of waste that comes to landfill, that beats everything from the standpoint of material and energy consumption. But if it is come to the landfill site, these are some of the measures that are being worked at this point of time. So that's a bit on the technology. And let me just stop sharing here. And I'll be happy to take questions and from the students later as we go through the flow of this session. Thanks.
Thank you. I'd like to ask a slightly more general question now to the panelists, specifically in the ambit of bureaucracy and how the government supports or otherwise these sort of green tech projects. Whether it's by incentives, grants, or certain think tanks like Niti Aayog specifically work under monitoring sustainable development for the country. So how does that all play into sustainable engineering? I think anyone who can give their insight on this is welcome to answer.
Yes, I can speak about specifically. I can speak about specifically about our field. I won't like to generalize these comments. My sense is that government is not a key driver on innovation. Essentially, technology needs to come to a certain level of provenness before other stakeholders jump onto the bandwagon, see what is possible. In some ways, you have to forge a bit of the future. you have to make it available in bits and pieces. You have to essentially provide a glimpse of the possibility before the enabling framework, for example, of government and other bodies starts coming into play. That said, it's not that there is a complete deficiency of an enabling ecosystem, but I mean, these are not efforts that you essentially shoulder on the back of supports from either government bodies or third-party grants. I mean, innovation by its very nature is something that may require a long haul. I spoke about that before, that you can't see past the corners. So I think, for example, specifically in India, the government has only very recently, as I said, this problem is about 70 years in the making. And even if you look at the extended producer responsibility framework, which is just starting to come up, in 2019, we had some drafts, and it's fairly dysfunctional and broken at this point of time. The government has invited comments, and there's been a deluge of them. So, I think even it will take some kind of enabling legislation is still maybe a couple of years ahead. But that's it. I mean, if you can demonstrate a cash flow positive solution that addresses the pain point, then really there is less and less relevance for the support needed from other stakeholders. And I think that's a good place to be. That's an aspiration for a technology or innovation driven startup to be. Be happy to hear also comments from other panelists here. Thank you.
Yes, Mr. Kalbag, if you have anything to offer.
I'm not very familiar with these aspects in terms of sustainability things from the government, because we are essentially in the rural development area, and we do a lot of work where there hasn't been any precedents. So in case you want to do some kind of work which is out of the box thinking, and you want to get actual results on the ground to show, then very often we look at it as keep the government out of it. Because, for instance, the government being huge and very difficult to maneuver, it's like wanting to go on a jungle trail in a truck. It's not very practical till the road has been built up, and then maybe the heavy vehicles can come in. So if you are right out in front and you want to make a lot of progress, then best is, from my perspective, to keep the government out of it. The other advantages by keeping the government out of it is then you are dealing most of the time with the people for whom you are doing the developmental work. And if they find it beneficial and value added in what you are doing, then we have seen that they are willing to pay for it. And if that happens, then we have a sustainable model which can go forward. And so the government also then latches on and says, okay, this seems to be a sustainable model because it doesn't cost the government too much. And therefore, they are willing to promote it. So it's a kind of chicken and egg. But yes, where we work right in the front and deep rural areas, we prefer to keep the government out so that we don't have too many bureaucratic hurdles to cross. Thank you.
Mr. Pandey, as someone who works for the government, what is your opinion on this?
Yeah, I can give you a couple of examples from the energy side. If you see on the demand management side, there was this immediate need to, when we expanded the grid and included more and more villages and more rural areas to be connected, there was this immediate requirement of demand side management. So if you recall around 2015, and one more thing before I said, the basic requirement is at the rural level and household is illumination. and just bare minimum, either one ceiling fan is running and a couple of incandescent lamps operating. So that was the first objective. So the moment you provide that access, then your demand suddenly shoots up. Okay, so that was the challenge before all of us. So what government did was that they started promoting LED lights. Okay, but if you recall, around 2015 or before that, the LED lamps were one LED lamp was as high as maybe 300 to 350 rupees per LED. Okay, so how do you bring down? How do you encourage people to buy those LED lamps, which are so costly? So there, the idea of this financial engineering was introduced, thought of, and demand aggregation was done. EESL, a company by name of EESL, was set up, and they were told to go and procure LEDs at a mass scale through an auction, instead of individual consumers going individually to a market, to a small shop and purchasing. The government aggregated the entire demand of LED and brought down the cost of LEDs to now it is somewhere, I think, around 35 rupees an LED. So, and that has given a big push, and people are now ready to, they are capable of buying those LEDs, and that has reduced our and helped us in peak demand management, particularly the lighting demand. So that was one example. Then the second example was when we wanted to extend electricity to far off places, then we found that this entire concept of extending the grid to very far flung places would be really financially unviable. So solutions, off-grid solutions were thought of, and that is where these technologies of solar pumps were introduced. And now we have a full-fledged government program of PM by the name of Pradhan Mantri Kusum program, which encourages the farmers to set up solar pumps at their farms, and then they are also encouraged to connect those pumps and those small solar stations to the local domestic distribution grid, wherein they can get back some amount of surplus energy. They can get back some revenue out of the surplus that they may not be using. So this Kusum program is again another example where direct government intervention push is helping one way in extending, in providing electrification and providing access to electricity, and on the other way, unless there is a return back to the person who is investing, apart from the grants and subsidies that they do get while setting up, they can get some revenues, additional revenues, which is a substantial sum for them. So then a third example that I would like to give is this transportation sector, if you see, is a big guzzler of energy, and we are heavily dependent on oil, which is largely imported from Gulf countries and other countries. So there was this thought of ensuring energy security for our country, and we wanted to reduce the consumption of oil, imported oil, and reduce our dependence on that oil strategically as well as for energy security needs. So that is how this entire concept of pushing for green energy was coupled with energy security, because now we can have energy from our resources which are indigenous. We are blessed with solar irradiance to a large part of the year, and we are in fact blessed with that compared to other Western countries. And likewise, we have huge coastline, and we also have large areas where we can produce energy through wind technology. So that is how this energy security and this was combined together. Now coming to the transport sector, since we already have this electricity and more RE sources coming in, we are more than surplus now. So we now want people to switch over from brown power to the green power. And that is where this electric vehicle concept and replacing this diesel and petrol vehicles with EV has come in. And there also this concept of demand aggregation is being applied to reduce the cost of electric vehicles. And if you recall, Tata Motors won that auction, and they were given the first to produce the first batch of, I think, some 10,000 electric vehicles and provide. In fact, in our own office, we have got an electric vehicle for ferrying people to the office in this COVID time, where we can't rely on public transport or public taxis. So we are using those electric vehicles. We have a charger. So that is how government is giving a push. Certainly, there are challenges and there are limitations. Government has resource limitations also. Then another example that I can give you is, again, using contractual and financial engineering. Like if you recall, generation from solar PV and even wind, around 10 years back, 1 unit of energy used to cost of something around 15, 16 or 20, and at times 30 rupees also. So how do we bring down that cost? So to bring down that cost, this concept of reverse auction was introduced, wherein the government started with a benchmark rate, and then bidders were asked to give a discount on those rates, compete for supplying those solar or wind power stations at a discounted rate. And now we have a situation where the per unit of electricity from a solar plant is as low as 2 rupees 50 paisa a unit. And now there is a different kind of problem that are arisen. The old power purchase agreements, which were signed at a higher rate, say 15 or so, now they are saying, no, we no longer want to honor those contracts, and a new kind of problem has emerged. But having said that, there are ways and means to resolve it, and that is how, apart from the technological innovation and apart from all that, what you need is a sustainable economic solution and some large part of contractual or financial engineering that has to be built in to create a self-sustaining kind of situation. So there are ways where, unless the government pitches in, you can't really have a mass deployment. So once you want to have mass deployment and mass adoption of any technology, I believe, yes, the value proposition has to be strong. But then looking at the diversity and the huge scale of our own country, government intervention, government push certainly helps. Commitment of the government, it certainly helps, and it has been helping, at least in the electricity power sector.
Thank you, sir. Dr. Rao, if you would like to add anything.
Yeah, I mean, a lot of interesting points have been already said. Yeah, I should also agree with Mr. Pandey, because I'm also from a government institute. So I agree on the part that government has a huge potential to support these initiatives. I'm not sure whether government is doing everything that is possible to do. But yes, definitely there is a huge potential to support these initiatives. Mainly the policy push that it requires. I mean, and it is evident that it has been done in few cases. I mean, going back to the basic issue of creating environmental awareness, I think introducing environment as a subject right from the school age, and now even the engineering curriculum has a compulsory course on environmental awareness. I think that is one good step in that direction. So, and the new education policy that is coming, which is now going to have emphasis on working with hands and vocational training, and then trying to make the education more in tune with the needs of the day. So I think government definitely is a huge body that we cannot ignore, and it has this potential to bring in all the positive things that are required in the response to the kind of crisis situation we are facing. Now, if we take the example of climate change, which is the one of the immediate issues that everyone is worried about. Now, in that context, now what government is doing, how renewable energy is being promoted, whether we are doing correct pricing of carbon and the fossil fuels. So all these issues, and I don't know whether government has done enough, but then I believe that government has a lot of potential to take up these issues in the right way. Thank you.
Thank you, sir. So we have a couple of questions from the audience now. I think, Mr. Pandey, I think this would be most pertinent to you. Someone has asked how long it will take for India to be integrated under a single power grid, and what are the challenges and the opportunities for grid engineers?
Oh, we are already integrated. We are we had 5 regions earlier which were operating in an asynchronous mode, but now we have single integrated grid right from Ladakh to Kanyakumari and Gujarat to Arunachal Pradesh. In fact, we have extended our footprints, as I said, to Bhutan as well, and India is also now supplying power to Bangladesh as well. And we are also connected to Nepal, we are connected to Myanmar, and there are plans to extend it further. In fact, there are lot many hydro projects coming in Nepal and Bhutan, large hydro projects, and they would be connected to the Indian grid. And if you recall, recently we had another very ambitious plan floated by India itself, that is one sun, one world, one grid. Okay, so that concept also has been introduced from India, and we have an international solar alliance wherein India is taking a lead role. So many things, there is lot of things to learn, and but to answer specific answer to the question is, we are already one integrated grid. I said we are operating at a single heartbeat. That is very rare. We are the largest in the world as far as synchronous grid is concerned.
Thank you for your answer. One more question, I think this generally applies. What is sustainable energy with regards to the pure IT sector, apart from its application in other domains? So anyone who can answer this, I think is better.
Can you repeat that question? What exactly?
Yeah. So basically, I think an IT engineering student has asked this. How can an IT engineering student help in the sustainable energy engineering sector?
Let me take that question, because we are applying that in our context also. See,
Yes.
To produce electricity, we have different sources. Okay, we have coal, we have nuclear, we have hydro, we have now renewable sources, wind, solar, and so many biomass, everything. Okay, now we have different sources, and all these sources, they are at different charges. Like the cost is different for each of them. And on the other hand, you have a set of demand that has to be met. Now, how do you ensure sustainability? You can ensure sustainability by optimizing, okay, by optimizing the resources that you are using. And that concept we have applied at a mass scale in the Indian grid. We have moved into what is called the security constraint economic dispatch, okay, wherein all India, since we have this benefit of interconnected systems, now we are able to do a merit order operation, and in real time, just 15 minutes before the actual dispatch of a generating station, we run an engine algorithm, which is the economic dispatch algorithm, and we see which are the resources which are online and what is the anticipated demand that we have to meet. So we start stacking up those resources from the cheapest to the costliest. Okay, and through this mechanism, through this economic dispatch, every day we are saving more than 3 crore rupees every day. And that is a rough average figure. At times it goes as high as 4 crores or something like that, when we have extreme scenarios of maybe low demand and we have to reduce generation. Those times the savings are more, because then we can reduce the costliest ones, maybe a gas station running on liquid fuel, high-speed diesel. So, and all that has been possible without spending a single penny on any power station. It is all possible because we created IT tools, information exchange, collecting information from power stations which are online, and so all they had to be connected. It is all pure IT solution that has been implemented, and it is producing big results. And these days, if you see so many utilities, they are under financial stress, and under those conditions, if we are able to save money to then give back that money, and the beauty of that is this 3 crore is given back to those utilities in certain proportion defined by the regulator, of course. But then if you see stressed utility getting back some money and still getting all revenues, everything is protected, and still they get some. So it has been possible only through IT solutions. So IT has a huge scope in creating, optimizing and creating solutions. Everything. The moment we have information exchange, everything is brought to one place. A lot of things, innovative things can be done, and that is being done.
I would like to give a slightly different perspective. As an IT engineer who is basically, as I understand from the question, you are probably writing code or you are developing algorithms. And in that perspective, if you are going to talk about being frugal, it essentially boils down to saying how efficient your code is going to be to achieve the same result, in the sense that if you can do it with, let's say, 10 lines of code and achieve the objective, which otherwise would have taken 50, then I think you would have been more sustainable from that perspective. So even as an IT engineer in your core field, you can try and be more innovative and think from first principles to basically be more frugal in your use of resources. Thank you.
Dr. Rao, I think you wanted to say something.
No, I was just going to say on the lighter note, I think if the IT engineers continue to work from home, as many of us are doing during this COVID era, it is, I think, helping a lot in terms of a lot of environmental issues getting sorted out of traffic and congestion and pollution. So I think that will be their bit to do the sustainability pitch. And then the whole thing, I mean, now we have slowly got used to these online platforms where the education is online, the meetings are online, all the unnecessary travel has been avoided for conferences, meetings, etc. So I think IT is enabling all these things possible. So I think they are contributing substantially to the sustainability on this planet.
Mr. Tandon, maybe as someone who has experience working in the software industry, maybe you can give some insight on this.
Well, I would tend to agree with Dr. Rao, what he spoke. In fact, I think there is a lot of IT enabling infrastructure which has positive effects in terms of emission reductions, in terms of how things are done more efficiently. And when you do things more efficiently, you essentially are minimizing the amount of resource allocation that it needs. Maybe just an additional minor point to make is that you can look and study the whole field of what's called clean web technologies. So inside the field of clean tech, there is a specialization called clean web. And there are hundreds of companies and many incubators which are targeted towards clean web. Clean web is essentially at the intersection of computer, IT, software, and environmental technologies. So there's a very good, well-placed intersection, which encompasses several different kinds of work. And maybe the questioner can go and read a little bit more about it. I'm sure they would like what they see.
Thank you, sir. So yeah, I think we'll wrap up with this session. We've already actually overshot the schedule we had. But thank you very much to all the panelists. I'm sure every single student and every faculty member that attended this session has learned a lot in terms of sustainability, how different fields of engineering come under sustainable engineering. And I'd like to now invite the other technical secretary of DBIT, Taha Kazi, to deliver the vote of thanks.
Hello. Good afternoon, all. I would first of all like to express my deepest, sincerest thanks to all our panelists. Mr. Kalbag, thank you. Dr. Rao, Mr. Pandey, Mr. Tandon, thank you. Thank you for spending your time and your words with us. I truly appreciate that. Then I would like to thank Principal Ma'am, Mrs. Nambiar, for constantly motivating us, pushing us to go towards this topic and doing this. Thank you, ma'am. Then I would like to thank all the technical faculties who are part of the technical committee, who helped us, who guided us in setting up this entire event. Then I would like to thank the entire team that goes behind it, the people who work in the background, right from certificates to posters to sending the messages on the WhatsApp group. I thank them. I would like to thank Priya ma'am, who's our technical convener, for helping us, for guiding us throughout the entirety of this event. Thank you, ma'am. I would like to thank Swati, my fellow TSEC, for being a great moderator. And finally, I would like to thank the audience that has been viewing this on Zoom as well as on YouTube. Thank you for being part of this. Thank you for listening to this. And hopefully we can have much more discussion like this further. Once again, thanks to all. Thank you all the panelists. Hopefully we can have such great conversations again. Thank you so much. Also for the audience members, your feedback form is given in the YouTube link as well. Thank you.
Thank you.
Well, thank you for coordinating this. It's been a pleasure.
Everyone.
Thank you.
Thank you. It's been a
Bye-bye.
pleasure. Bye.
Thanks for the
Bye.
opportunity.
Bye-bye.
Thank you.
And happy Engineers Day to all.
Yes.
Yes,
happy
yes,
ending.
absolutely.
Happy
Engineers Day.
Happy Engineers Day.
Absolutely.